Hello, this is a short video presentation on solving a system of equations with 3 equations and 3 variables. This is somewhat more complicated than what we've been doing, so you need to be extremely organized in your work. Please show your work in the same manner that I show it to you. I also apologize for the sound quality, but I left my microphone at home, or at school, and so I'm using the internal microphone, which isn't quite as good. All right, let's begin. So, what we want to do is use elimination twice. And what I mean is, we are going to take the first 2 equations and we're going to eliminate x. Then we're going to take the last 2 equations and we're going to eliminate x. So we're going to do 2 separate eliminations of x. But when we're done, x will be gone. And we'll only have 2 equations left and 2 variables. So what we're going to do is we are going to multiply the top equation by 2 and the bottom equation is going to be multiplied by 3. So I end up with 6x minus 4y minus 8z equals 2. And the bottom equation, middle equation, I get minus 6x plus 3y plus 9z equals 3. And now I'm going to add these 2 equations together, and when I add them together, I get no x's, my x's cancel, and I get negative y plus z equals 5. And now, I'm going to switch colors. I'm going to look at the bottom 2 equations. So I'm going to multiply the middle equation by 5, and I'm going to multiply the bottom equation by 2. So I'm manipulating the middle equation twice, 2 different times. So now I have 5 times negative 2, negative 10x plus 5y plus 15z equals 5. And the bottom equation is positive 10x plus 8y plus 2z equals negative 10. And when I add those together, the x's will cancel. I end up with 13y plus 17z equals negative 5. All right, slide over here. And now I'm dealing with 2 equations with no variable of x. I have this equation with y and z, this equation with y and z, and now this is easy to solve. I'm going to take the top equation and I'm going to multiply it by 13, and the bottom equation will stay the same. So I end up with negative 13y plus positive 13z equals 65. And we have 13y plus 17z equals negative 5. I add those together, my y's cancel, and I end up with 30z equals 60. Divide by 30, divide by 30, z equals 2. All right, now we just go back like we have been, I'm going to use this equation right here, and I'm going to find out what y is. Negative y plus z, z is 2, equals 5. Subtract 2. Negative y is equal to 3. If we multiply or divide by negative 1, we find out that y is equal to negative 3. So, last thing we have to do now is find out x. So we go back to our original equations, or any equation that has an x, and I'll use the last equation, I'll use the top equation. So we have 3x minus 2 times y minus 4 times z equals 1. Y is negative 3. Z is positive 2. And we solve. 3x plus 6 minus 8 equals 1. Combine our like terms. 3x minus 2 equals 1. Add 2 to both sides. We get 3x equals 3. Or x equals 1. Now instead of writing our answers as ordered pairs, we write them as ordered triples. X is 1, y is negative 3, and z is 2. And the order is alphabetical, x, y, z. And just for your benefit, I'll write that down here, x, y, and z. All right. Let's go back. Just look briefly at what we did. We wrote down the equations, and I took the middle equation and the top equation and eliminated x. Then I took the middle equation and the bottom equation, I eliminated x. So the middle equation is written down twice. Of course, it looks different each time. I then had two equations with no x because I eliminated the x. And then I solved these two equations using substitution or elimination. In this case, I was using elimination, but it doesn't matter to you, or to me, or to you for that matter, whatever you prefer. And now we found z, and then just like we've always done, we put it back into one of these two equations, and we find out the other variable y, and then we substitute them both into one of our original equations, whichever one looks the easiest to use. All right, I hope this helps, and again, I apologize for the sound quality, and have a great day.